These are the first four problems from the Glencoe geometry book, an extra practice section for lesson 8.4, all based upon the triangle ALN shown at the top of the screen here with a right angle at 90 degrees there. The first problem says given measurement of A equals 15 degrees and AL equals 37, find LN. So the first thing I'm going to do is mark the 15-degree angle with a little red mark here, and I'm going to label AL, which is here, as 37. Now, if we're looking at angle A, which is 15 degrees, and we'll live with the bad 15 here, we have to identify what legs are what. We want to find LN. I'm going to call that X. What we have to first notice is that X is the opposite leg when using 15 degrees. And the 37, since it's across from the 90-degree angle, all right, anything that's across, that is always the hypotenuse, so we'll call that H. So I have O and H. Using Sakatoa, which is basically a little easy shortcut for us to remember. It's sine, which is the opposite in the hypotenuse, cosine, which is the adjacent in the hypotenuse, and tangent, which is the opposite adjacent. This time we have the opposite and the hypotenuse, which takes us to sine. So we will write the trig ratio, sine, and we always have to have something here, sine of 15 degrees is equal to, okay, well, it's opposite over hypotenuse, it's x over 37. And now trig is over. Once I've written this, trig is over. We have written now an equation that needs to be solved. Sine 15 is one thing. If you take your calculator and you type it in, it's actually 0.2588. But we'll leave it as sine 15, and we will just get x by itself by getting rid of the fraction. Since there's an equal sign, I'll multiply both sides by 37. And if I had a unit, say 37 meters, 37 centimeters, that would go with it. So x equals 37 times sine 15. And our answer for x here is, to one decimal place, to the 10th, is 9.6. So x is 9.6 for number 1. This is what you should do in all trig problems. Set it up. I'm just going to get the work for the next 3 so you can see the answers. On problem 2, you're going to see the answer should be 13.7, and the trig ratio is right here. Sine of 47 equals 10 over x. Again, the opposite of the hypotenuse with the legs used here. This time it's an extra step to solve because x was in the denominator and it had to be multiplied to the top. It's shown in this step right here. And once you get that, you get this equation. X times sine of 47 equals 10. That's one term on each side, so we had to divide by the sine of 47 on both sides, and that resulted in an answer of 13.7. Problem 3 gives the leg, then the angle, still a leg and an angle. They say angle A is 16 degrees. The leg between A and N is 13.4, and this time they want AL. And as you label the triangle seen above, up here, you'll see that 13.4 is the adjacent, x is the hypotenuse, AL, which gives us cosine. So we set up our ratio. Cosine of 16 equals adjacent over hypotenuse, AH, 13.4 over x. Multiplying both sides by x. Again, once you've done the ratio, set up the trig, it's just algebra. You get x times cosine 16 equals 13.4. Divide both sides by 16 cosine, which is a value. You get x by itself, and you find that x, or the hypotenuse, AL, is equal to 13.9 for problem number 3. The fourth problem in this set of 4, using the same triangle ALN, gives the measure of angle L at 72 degrees, shown here. AN is 13, and LN being the unknown, which again I'll call x. Again, labeling from the 72. 13 is the opposite because it's across. Hypotenuse is still AL, but we want X, which is adjacent. All right. O and A makes this a tangent. You'll see here tangent of 72 degrees, then equals the opposite, 13 over X. Again, we can take this, now we have the green trig equation. By multiplying by X on both sides, we can make this into the second line here. X times tangent of 72 equals 13. Divide both sides by tangent of 72, which again is just a decimal. So 13 divided by tangent of 72 gives you the answer for ln. ln is equal to 4.2. That wraps up these 4 problems. Keep practicing, keep writing the trig ratios.